Hi everyone, in this tutorial we are going to be discussing our second type of stereocenters, the sp3 carbons of cycloalkanes. It is the case that cyclic structures can cause a restriction in carbon-carbon single bond rotation, and this restriction in rotation often lends itself to this idea of having cis-trans stereoisomerism. Cis as a term refers to two groups being in the same direction in 3D space, and trans refers to them being in opposite directions in 3D space. Let's look at some examples. These two carbons are considered to be stereocenters. They are carbons at which the interchange of two atoms or groups produces a new stereoisomer. At this carbon here, we have a hydrogen and a hydroxyl group. We are going to imagine interchanging them, flipping their wedges. As a note here, they do not interconvert, right? We are manipulating the structure to make this consideration. We have gone from them having opposite perspectives. These would have been trans, that's how we classify them. And once we've interchanged the OH and the hydrogen, we have now made there be a cis relationship between the OH and the methyl group. And because we have interchanged two atoms and or groups and made a new stereoisomer, this is a stereocenter. We also could have done the same thing at the carbon with the methyl, and both of them are stereocenters. We have now a case where we have a 1,4 relative positioning, a 1,4 di-substituted cyclohexane ring. Both of those carbons are stereocenters. We can see cis-trans isomerism. At this position, we have an isopropyl group and a hydrogen. We're going to interchange those. Here they have been interchanged, and this is a different isomer. We have the cis isomer, and now we have the trans isomer. The isopropyl and the CH2Br were cis to begin with. After this interchange, they are now trans. Because those are different stereoisomers, this is considered a stereocenter, and this is considered a stereocenter. Notice how there is symmetry about this ring. Let's track this visually. From here, we go to that carbon and that carbon, they tie. We go one further down, they tie. We go one further, and we see the symmetry about the ring structure. What that means is neither of these carbons are asymmetric centers. However, we still see stereoisomerism here because of the ability to have cis-trans relationships between the two groups. Okay? So really important that we understand that asymmetric centers are sp3 carbons bonded to 4 distinct atoms or groups. They are a type of stereocenter. But so are these carbons here that are not asymmetric centers, but are still stereocenters because of cis-trans capability in the structure.